Okay, so I've got a beam that is put together like so, okay, with nails. Notice there's two sets of nails, some across the top and then some on the side there. Okay, each nail can hold 100 pounds. I want to figure out what the spacing is if I've got 700 pounds acting straight down. So again, the equation I'm going to use is lowercase q, which is the shear flow, which is the force per length, and that equals VQ over I. Okay, so again, the force will be the 100 pounds. The spacing is what I'm trying to find. V is 700. I'm basically looking for Q and I. So let me start by finding I, because I'm going to have different Q's on this. Okay, and we'll come back to that in a second. So I need to find I about the neutral axis. So I guess the first thing I need to actually find is the neutral axis. So break this up into some chunks here. So from the bottom, I got the first one is going to be 5 times pardon me. Okay, I think we're back to looking good. Sorry about that. Okay, so that's going to be 5 times 1.5 by 10. Okay, then I'll have the next one, which is 10.5. That'll be the top one. The location is 10.5, and then it is 10 by 1. And then I've got two of these other guys, these little guys. Okay, and they are, let's see here, 10, 9.5 is the location. So 2 times 9.5, and then they're 1 by 3s. So 9.5, 1 by 3. And then I've got to divide that by the total area, which is be 1.5 times 10 plus 10 times 1 plus 2 times 1 times 3. And I find that the centroid, the neutral axis, is located at 7.645 inches from the bottom. Okay, so now that I have that, I can find I, and then I'll move on to the Q's. Okay, so I again is going to have 4 pieces. Okay, so I'll start with the big one. So this is going to be 1/12 BH cubed, where B is 1.5, H is 10 cubed. Okay, then plus 1.5 times 10 times, and then this would be 7.645 minus 5 squared. Go to that top one there, so this can be 1/12. This will be 10 by 1 plus 10 times 1 times, and then this is the location of that, the center of that one is 10.5, so from the neutral axis, so minus 7.645 squared. And then I actually have 2 of these guys, so let me put a 2 out in front. Okay, because I got 2 of the little guys, and then BH cubed, which would be 1 by 3. So 1, 1, 3, and then 9.5 minus 7.645. Again, that's the location of the center of that guy from the neutral axis squared. So all of that gives me an I of 337.43. Okay, so now I've got I. Now, here's the thing. I've got 2 Q's that I need to look at, right? I need to find the spacing. So I'm going to look at this guy right here, which we'll call Q, and then we'll have Q prime for the S prime. And I'll actually, rather than looking at the top one where it's got 3 different nails coming in, I'll actually look at this bottom one right here. So we'll call that one Q prime. Okay, so do it right here. We'll say Q. Again, now this is for those little guys. Okay, so again, that's going to be y bar prime times a prime. So y bar prime is, again, it's 9.5 minus that neutral axis, 7.645. And then a is just 1 by 3. right? So Q on that guy is 5.56. Okay, and then Q prime is going to be that tall up and down guy where it's located at 5 inches. Okay, but from the neutral axis, it'll be 7.645 minus 5, and then its area is 10 by 1.5. So the Q of that one is 39.7. Okay, so now I can find S and S prime going back up to my shear flow equation. Remember, each nail can hold 100 pounds. So we'll start with S, so that'll be 100 divided by S, and then V is 700. And really the only thing here that changes is Q. So for this Q, it's going to be 5.56. I will be the same for both, and I is 337.43. So from that, I know that the spacing on those, the 1x3s, has to be every 8.67 inches. So not much. Those aren't seeing a whole lot of shear on there. Okay, so I can have some pretty far spacing on that. You'll see very differently on the next one where I'm finding S prime. So again, each nail here can still see 100. Difference here is going to be the Q. So instead of 5.56, I'm going to use 39.7. V and I are the same as they were before. And this is going to cause S prime, the spacing of those top ones, to be much closer together. It's going to experience a lot more shear flow going on there. Okay, and that shear flow is 1.215. So they have to be basically every inch and a quarter, which is pretty often. A lot of nails going along that way to withhold the shear flow that comes with a 700-pound shear. Okay, so again, you just look at the interface between where the nails are, where they're going to shear, and figure out the Q's for the different pieces, and then plug it into that shear equation.